record. I can hit the record, but who is going to upload it? I wish some of you would have done all this. Okay, so also in match case control studies, you can have you have the problem of two related groups. Let me repeat, just because we just started to record the session. If you have a numerical data, such as the tumor size in millimeters, and two related groups, as it is in this scenario, measurement 1 and measurement 2, before and after, then your test to do is the paired samples t-test. Or if you cannot perform this test, you do the non-parametric alternative. Non-parametric alternative, the Wilcoxon's test. The Wilcoxon test uses the median or the rank, while the parametric tests, they are relying on the mean and standard deviations. Okay. If you want to do the paired t-test, the parametric test, you have some assumptions. All parametric tests have similar assumptions. Normal distribution, the data has to be normal distributed in the population of interest. And we should have a reasonable sample size, Okay. So, yeah, what we are testing, you don't need to remember the formula for this test, but just be aware that it is a very simple formula actually. It uses the difference between the means, because the mean difference, this minus this, should be theoretically 0. If there is no difference between before and after, if you subtract 50 from 20, 40 from 40, at the end, the mean difference should be 0. So we use the mean difference divided by standard error of the differences. And the standard error, the formula for standard error, you should have in your mind. It was standard deviation divided by square root n. This is how we calculate the t-value for paired samples t-test. Let me demonstrate it with the SPSS. Here I have several different kind of data. And one of my variables is the height or weight. Weight. I have here the weight before in this column, marked blue, and the weight after some exercise. Weight, as you know, is numerical data. And if I made two measurements in weight, I can do the paired samples t-test, which is compare means the paired samples t-test here. Let me select the two weights. These are my two weights, weight and weight after. Click OK. That's very easy to do it with the SPSS. You see, the mean weight before was 74 kilogram, and after exercise, it became the mean weight 68 kilogram. And here you see the standard deviations. Okay, and there is a mean difference, of course. And is it significant or not? We have to check the p-value. This is the significance. The p-value is almost 0. It is never 0, as you know. It is close to 0. So if it is, what was the rule? If it is less than, if this value, the p-value is less than 0.05, we decide that this difference is significant. So we reject the H0. And we accept that there is a difference. There is a significant difference between before and after. That's very easy. Let me do the same test. But if I want to do this test, I have to check first whether this weight, this ağırlık in Turkish, this weight is normally distributed. Does it have extreme values or not? and I have to also have a reasonable sample size, which I have actually. It is 424. If I want to conduct a non-parametric test instead, if I cannot meet the assumptions and want to do the non-parametric test, then I select from the menu the two related samples. And here, there is weight, ağırlık, and diyet ve egzersizden sonra ağırlık. And you see, there are other paired tests, but we have to select the Wilcoxon, of course. Wilcoxon. Let us see what kind of output we have. The p-value again, asymptotic significance, two-tailed p-value is again less than 0.05. So we have almost the same result. But the difference is, you see in the Wilcoxon, no mean is reported. We don't see any mean. Can you see any mean values here? No. Instead of mean, we see the rank, because the Wilcoxon test, the non-parametric tests, rely on the median or the rank. Okay. If you remember this, that will be enough for me. The non-parametric tests, if you conduct the non-parametric tests, you will have the ranks. But if you conduct the parametric tests, the output, the computer output or your report will include the mean and standard deviations. Okay. Yeah. Anything else? That's enough, I think. Your questions I will try to answer. But since I have only 40 minutes to finish this two sessions at once, I will go directly over to the numerical data to unrelated groups. Numerical data to unrelated groups. Discard this. Have a blank screen. Now, the second scenario is we have again a numerical data. Numerical data. Please, can you give me an example of numerical data? Eileen? Mohammed Dawood has arrived. Welcome, Mohammed. Can you give us an example of a numerical data? Tumor size we said last time. No, something else, please. Anybody from the class? Come on, we don't have much time. Okay. Wait.
The amount of white blood maybe in the blood.
The amount of what? Blood?
White. Yes, white blood cells.
White blood cells. Okay. White blood cells. White blood cells. Or blood loss, let's say. Blood loss. Blood loss after an operation, after a surgical intervention. So weight will be centimeters or inches. White blood cell count. This is count. Count. Or blood loss will be milliliters. So all these are numerical data. And you want to compare two independent groups. Two groups which are not related. We have samples from two independent, unrelated groups of individuals with numerical data, sometimes also ordinal data. Ordinal data can be also treated as numerical sometimes, but for our learning purposes, it's enough if you remember numerical data. Okay? What is the example in the book here? We wish to compare the weights in two groups of children. Okay, so here we want to compare the weight of of males and females of a group receiving treatment 1 and the other group receiving treatment 2. We want to compare the white blood cells in between two patients using two kinds of medications. We want to compare the blood loss between two different surgical interventions, laparoscopic intervention and let's say open surgery. You can imagine that the assumptions to do the Ampere t-test, or the other name was what? The Ampere t-test?
Students t-test.
Sorry? What was the name? Can you repeat it, please?
Student t-test.
Yes, or student t-test. Students t-test. So, two groups, two independent groups. Such as male, female, such as intervention 1 and intervention 2, such as medication A, medication B. Anything you can compare. Okay? So, two independent groups. Then your scenario requires to do the Ampere t-test. The assumptions you can guess are the same as in all the parametric tests. Normal distribution, and here reasonable sample size, but here's something else additionally. We should have a reasonable sample size so that we can check the assumptions of normality and equal variances. Here we have also the rule requirement of equal variances. So the three assumptions. One, normal distribution. Two, sample size. And three, homogeneity of variances. I will explain what this is. Homogeneity of variances. This is a third assumption. If you cannot meet these assumptions, if the assumptions are not satisfied, the book mentions about the Wilcoxon rank sum test. What we will do, this is the parametric test here. Parametric test. The non-parametric alternative is in SPSS is what?
Mann-Whitney U.
Thank you. Yeah, Mann-Whitney U test. Okay, so this is the non-parametric alternative, and then now you can. If I ask you, you will be able to tell me that the Wilcoxon or the Mann-Whitney U test. You see here, they mentioned also in the book. In the previous version it was not mentioned. An equivalent test is the Mann-Whitney U test, gives identically the same results. So again, the t-value to be calculated here is very similar to the other t-values. Differences between the means, mean 1 mean minus mean 2, and divided by the standard error of the differences. Standard error of the differences, the formula is a little bit different, but again very similar. Standard deviation divided by square root n. Very similar, but not exactly the same. Let me do this with the SPSS, demonstrated with the SPSS. Analyze, compare means, independent samples t-test. Independent samples t-test. The variable I want to compare is weight. I want to compare the weight. I have to have two groups, let's say between males and females, sex. I want to compare. I have to define the groups. The group 1 I coded as 1. Group 2 I coded the males and females. I coded as 1 and 2. So if I click OK, let us see what we have. This is the student t-test computer output in SPSS. Let us see what we have here. We have the mean weights 77 kilogram and 70 kilogram. This is what we want to compare. But the independent samples t-test computer output gives us first something else, the Levene's test for equality of variances. So it performs a test to see whether these variances, the standard deviations, variance was the square of the standard deviation, the variances or the standard deviations are similar or not. Is there a significant difference between these two standard deviations? Namely, males have a standard deviation of 15 and females have a standard deviation of 13. Is there a difference between these two? Because our assumption was, where is it? Here. Our assumption was the variances should be equal, homogeneous or equal. Okay, so if you don't have equal variances, statistically equal, of course they are not exactly the same. 15 and 30 is in this case equal or not. This is the p-value. If the p-value is 0.509, what would be your conclusion? Are these two standard deviations equal or different? Is there a significant difference?
No.
No, thank you, Banu. No, there is no significant difference between 15 and 13 because the p-value, the Levene's test p-value, which is showing the equality of variances, is larger than 0.05. So there is no standard. Is it good? Yes, it is good because this was one rule, one assumption. These are assumptions, huh? Assumption or rules. Rules to conduct this. Normal distribution and sample size, enough sample size, and homogeneity of variances. So now we see that we have homogeneous variances here. Then we go ahead and look for the t-value, 4.1 t-value. How is it calculated, t-value? T-value, that's, you already know it. Here is the formula. You don't need to remember the formula for the t-value, but you need to know it is including the mean and the standard deviation. So the computer has calculated for us the t-value as 4, and from the t-value, he has done the integral analysis and calculated a p-value for the difference between the means. What can we conclude? Is there a significant difference between 77 and 70 kilogram between males and females? Is there a significant difference? Yes, because the p-value is small. It is less than 0.05. If you have a small p-value, the difference is significant. Let us say, of course, as you see, we met the assumptions. We have a large sample size, 230 males and 290 females, 93 females, and we have the variances. The variances are not different; they are homogeneous. And I didn't check the normal distribution, but let us say we have normal distributions. What would be happening if we cannot meet the assumptions? Then we have to do the Mann-Whitney test. Let me do it with the SPSS, and then we close this session. Non-parametric tests, 2 independent samples in this case, 2 independent samples. Here we have again the weight between males and females. I want to compare it between males and females. My grouping variable is sex. And again, I coded this 1 and 2 comes from where? From my coding. I have coded them, male and female. I have coded them as 1 and 2 here. You see, where is sex? Here is sex. 1 and 2. 1 is for males, 2 females, and 2 is for females here in my case. So the computer output for the Mann-Whitney test gives us, as you expected, the ranks. And here is a p-value again, asymptotic significance, two-tailed. The p-value is less than 0.05. The p-values you see for the t-test and for the Mann-Whitney test are very similar. But even though they are similar, sometimes they may be different. So it is crucial that you conduct the correct test. If you have to do the t-test, you do the t-test. Otherwise, if you cannot perform, if it is not possible, if you don't meet the assumptions, you go for the Mann-Whitney test. Yes, folks, that was enough, I think, for today. Just briefly, we have mentioned about the paired samples t-test and the independent samples t-test. The parametric test for the paired samples t-test is the parametric test, and its non-parametric alternative is the Wilcoxon, while the unpaired t-test or the student's t-test has its non-parametric alternative, the Mann-Whitney. Any questions before I close?
Yes, Mr. I didn't understand when you mentioned about when we don't meet assumptions. Like in which conditions we can't have the assumptions properly?
The assumptions are, there are 3 assumptions to conduct the unpaired t-test, the student t-test. The first assumption is normal distribution. If your data is not normally distributed, let me check if I have normal distribution here. Do you remember how we checked the normal distribution? We did it with the histogram, for example. I can perform a histogram here. I have a histogram now, and I want to see whether, oops, display normal curve. Click OK. Think, yes. Display normal curve. Apply. Click OK. Let me see whether the weight of my cases is normally distributed or not. If it is symmetrical, reasonably symmetrical, this is a little bit right skewed, but that doesn't matter because I have very high sample size. It is symmetrical. That means I met the assumption number 1. The assumption number 2 is sample size. And as a rule of thumb, we said that if we have around 30 participants, it is enough. So we have 400 here. We met also the second assumption. And the third assumption is the homogeneity of variances, which is checked by the Levene test. Levene test. Okay, and the Levene test is done by the computer, by SPSS automatically. It comes with the independent samples t-test. So since we have a high p-value here in the Levene, we decide that also we meet this third assumption. These are the 3 assumptions. If I cannot meet any of them, if I have a low sample size, or if I don't have a normal distribution, or my variables, my variances are not homogeneous, the Levene is significant, then I go over for the Mann-Whitney.
Okay, thank you, Mr.
You're welcome, Banu. Evet. So, any other questions? I don't know how I am going to upload this, where I am going to upload this, but I will try it. I will try to contact Dr. Azamat.
I am here.
You're
I'm sorry.
Here. You're welcome, Dr.
Yeah.
Azamat. Sorry, yeah. And it's not a big deal. This time we did it short summary, and we have the book. The students can go if they want to do a further reading. I summarized today the numerical data to related and to unrelated groups. And the students can go and read further from the book if they want. So let us say goodbye and see you next week.
See you, Hocam.
See you, hocam. Thank you.
See you, Mr.
Thank you, Begumay. Well
See
done.
you.
Thank
See
you
you.
all. Canan, Ermek, Aylin, Ayşe. Hepinize güle güle.
Görüşmek üzere.
Hoşçakalın. So, Dr. Azamat, tell me what I have to do. I have to stop recording first. Stop here.
Yeah.